Yes, we are live. So, hey, hello everyone, and I welcome you all to Rankplus JEE English. In this class, I'll be covering the simple harmonic motion. This is very important chapter for your JEE, and the knowledge which we will gain from this chapter will be helpful in the further chapter as well. So let me start this topic. But before starting, there is one thing which you have to do, and that is the must, that you have to join our Telegram, because in our Telegram group you will get the PDF of this video. Other than that, you'll also get the handwritten notes and the DPPs. So all and everything you will be getting on our Telegram group. So the link is in the description. Please join from that link. And the first thing first, we have to know that what is the syllabus here. Sometimes student feels that this syllabus is very fast and they are not able to complete it, but I always tell them that syllabus of JEE exam is very finite, and if you see it from the official website, you will get to know that there are very few points which you have to cover. So according to JEE 2025 syllabus, we have these 7 points which needs to be covered. So in this class, what I'm going to do is I'll be covering each and every topic one after the another. And once we are done with this, I'll be covering or I'll be solving the JEE 2024 questions which was there in your January attempt and the April attempt. So my main focus is to give you the complete theory, and other than that also give you the real practice of the exam questions. Okay. And when we are dealing with all these things, I'll be also sharing my unique technique to solve the numericals related to the simple harmonic motion. So this is how we are going to proceed for this session. So let me read the first topic for you. What is this is the oscillation and periodic motion. We have to know that how we can find out the time period and the frequency. Okay. So before we start, I want you all to please share this session with your friends so that there will be more motivation, there will be more energy, because when you are there, the energy in me will be high. So shall we start it? PG, Ragul, can we start? I hope that I'm audible and visible to each of you. Let me start this session. The first topic, what we have to complete is at what is periodic motion. We are already done with the kinematics, in which we have studied the motion. And again, when this class 11th topic ends, there is a topic what we have to study is periodic motion. When I am telling you that a motion is periodic, what does it mean? What does it actually means? It actually means that after a fixed interval of time, the data related to the motion repeats. Very simple definition, right? After a fixed after a fixed interval of time, the value or the data of the motion repeats itself. After a fixed interval of time, the motion repeats itself. So all the data will be again same after the fixed interval of time. So when I'm telling you the fixed interval of time, what does it mean? It means that the displacement, the velocity, the acceleration, each and everything will be similar what was there before that time, before that fixed time. There are so many examples which I can state here. The first example, as you all know, is the clock. If you see, normally in clock we have three hands: a minute hand, second hand, and the hour hand. Okay, so let me tell you, this is my minute hand, this is my hour hand, and this is your second hand. It's not that second hand books what you generally uh, borrowed it from somewhere else. So these are my hands of a general clock. So I know that after 60 minutes, this minute hand will be at the same location, right? If my watch is moving, what it? Wait a minute. There is some issue from laptop. Wait. Just few seconds. Yes, now it's done. Charging was not happening. Now the time period for this is 60 minutes, right? After 60 minutes, it will be at the same location. And for the second hand, we have time period of 60 seconds. Now, there is a tricky question. Once I explain you that minute hand time period is 60 minutes and the second hand time period is 60 seconds. And if I'll ask my student that what is the time period for the hour hand, can you tell me? Please let me know in the chat. Please tell me that what is the time period for the hour hand. That after how many hours, how many minutes this hour hand will be at the same location. TG, Raghul, please do let me know. Do not be silent. Come on. Array, it's 12 hour, right? It's 12 hour. The time period for this is 12 hour. Right. Next example, I could also give you the motion of planet around the sun. Second example can be a motion of a planet around a star. So this was my periodic motion, and there is also a special type of motion which is known as oscillatory motion, which we have to study in this chapter only. The second one is the oscillatory motion. So oscillatory motion is basically, it is a special type of periodic motion. It is a special type of periodic motion which type of speciality this motion is having, that this motion happens when the object is moving to and fro. So there is to and fro motion. And do you know what is to and fro motion? In to and fro motion, we have one mean point. We have some mean position. Let me assume that this is my mean position. And an object can move in this direction, right hand side, and it can again come back, can goes again here, and then it moves here. So basically this is the to and fro motion. Okay, so I can say that every oscillatory motion is a periodic motion, but not every periodic motion is a oscillatory motion, right? So I can write a note that every oscillatory motion is periodic motion, but every periodic motion is not oscillatory. Can you give me an example that a motion is periodic? but it's not oscillatory. What is special in oscillatory motion? In oscillatory motion, basically the object is going away from us and then again it is coming back, right? So you have to remember this chapter is all about, see, there is one approach which is known as my approach, Manoj Sir approach, MS approach, and the approach is basically whenever we have to solve any numericals related to the simple harmonic motion, what we need to do is we have to think in terms of the example, we have to think in terms of the equations what we have in this chapter. So this is the only thing what you have to keep in your mind. You have to think in terms of, you think in terms of, think in terms of examples, and there are very few examples which you need to remember. I'll be giving you each and every example and I'll explain you also. So you have to think in terms of examples and equations. There is simple harmonic equation as well. Okay, I hope that this is clear to you. And there is one more point which you need to write. Some students are often confused that the what is the basic difference between the oscillations and the vibrations, because these are almost similar, right? These oscillations and vibrations are altogether similar things. Third one is that if you ever got the oscillation written in the question or the vibrations, it's altogether means same. Basically vibrations means that the amplitude is very small, the frequency is large, right? So for vibrations I could say that frequency is large. When frequency is large, I am generally says that the object is vibrating, and when frequency is small I prefer to say that oscillation. But it's altogether same thing. You do not need to take any tension for that. You have to only think these terms what I am telling you when you are getting a question, and you have to mark the correct answer, right? Then you can say that vibration is basically the oscillation where the frequency is large, and oscillation is oscillation where the to and fro motion is happening, because both of them, in both of them, the type of motion is to and fro. In oscillation and vibration, the type of motion is to and fro. These are basically to and fro motion. Okay, so this is basically a to and fro motion. Let's now, is it clear, my dear? Cyber and science creation. Wow, a great name. Is it clear, my? Is it clear, my dear? Now let's start a very important topic in this, which is known as simple harmonic motion. Which is known as simple harmonic motion. What is this simple harmonic motion? Sometimes student who got whose favorite topic is simple harmonic motion, they usually say it like SHM, simple harmonic motion. For SHM, we have basically two types of SHM: a linear SHM, right? Linear SHM, and a rotational SHM, where we generally considered that there is some angle, there is some omega, right? So those terms we will be covering. So you can also name that as angular SHM. So we have two different types: linear SHM and the angular SHM. SHM is basically the simplest type of oscillation motion. Simply, you can say that SHM is the simplest type of oscillation simplest type of oscillation. Okay, so there are some conditions for SHM. There are some conditions for SHM that you need to remember, because then only I can say that the motion is SHM, and you can apply all the laws which I am going to teach you. Okay, for for a motion to be a SHM, the first thing is that the motion should be an oscillatory motion, right? A motion should be an oscillatory motion. That is the first condition what you need to do. The other than that is the path. I'm first telling you about a linear SHM. So path of the motion must be a straight line. A path of the motion must be a straight line. Okay, and there is an acceleration which is proportional to minus of x. The power must be 1. You can also write that there is some restoring force. There is some restoring force which is acting there, and that restoring force is also proportional to minus of x. You can say that the displacement which is happening from the mean position is the value of x. I'll explain you that thing, but these are the three conditions what you need to remember. Other than that, other than the oscillatory motion, that when the motion is oscillatory, there are some few conditions which you need to look out for tagging that motion as an SHM. The first thing is that motion must be in a straight line to and fro, that something is happening. And the second thing was that acceleration must be proportional to minus of x, and the force is proportional to minus of x. I hope that this thing is clear to you. Acceleration will always act towards a fixed point. Is it clear, my dear? Let's further, I'll elaborate this thing. When I'm talking about a linear SHM, there is first example which I'll take here. This is my example number 1. Consider a table. And on this table, coloring this to demarcate it. There is a green table, and on this green table we are having a spring is attached to and that is the natural length of the spring. Okay, for checking it, I'm marking this, that this is the natural length, and I'm marking this length, this point as O. And now if a person do one thing, that he stretches this, he stretches the string, and he does one thing. We have extended this length to this x stressed. This one is stressed. This one is at natural length. Again, now again, I'm keeping it here. I also need to move this thing here. So I'm keeping this thing here. Now this time what I'm doing is I'm compressing this thing. So this is the value of x. This one is compressed. This one is compressed, this is natural, this is stretched. Okay. So basically, if you look out this thing and I'm combining, and if I'll combine this thing, I could write that there is one point which is known as O. I'm combining all those things. There is one common point which is known as O. And if this object is extended to the maximum what it can be, I'm marking this as plus A. And this is the plus A. So I'm writing here plus A. And now once it's compressed, I'm writing here at minus A. So you can write it here minus A. So basically, when I'm telling you that SHM is happening, you have to think in this term that what if I stress this spring? What if I stress this spring and leave it? Then what will happen? It will move like this, right? It will move like this. So I can write, or you can imagine that if there is a person, first it moves here, then again it's come back, then again it's moved to the extreme left, then again it is going towards the mean position, and once it reaches here again, the same location, then I'm telling you that one complete round is done. Are you getting this? So for a complete one round, there is 4a distance what an object can cover. Are you getting my point? That for a one round there is a 4a distance what an object will cover, because from 0 to here the distance will be plus a, then again the distance covered by is a, then again from 0 to minus a the distance is a, then again from minus a to 0 the distance is a. So it means that for a complete cycle the distance traveled is 4a, right? I hope that this thing is clear to you. Now there is another point I need to enter, that this object is moving to and fro. This motion is known as oscillation. This object is basically moving to and fro. This motion is known as oscillation. And if this motion is happening in a straight line, the first condition what we were having for a simple harmonic motion, that an oscillatory motion can be a simple harmonic motion, and that too for a linear type, that when the path of the motion is a straight line. So here the path of the motion is a straight line, right? Similarly here, if you compress this spring or if you stretch this spring, the path will be a straight line. So here the path will be a straight line. The second thing is that the acceleration is always towards a fixed point. The second point is that the acceleration is always towards a fixed point, that if you are moving this object away or towards, if you are moving, or I can say that if you're diverting this object from the mean position, then what will happen? If you are diverting this object from its mean position, then what will happen? There is always a tendency to come back again. So in SHM, there must be a restoring force, that whenever you are moving an object from its mean position, it always wants to come back to its original location. So what I am telling you, that if you are moving this object, let me tell you that if you have moved this object to a distance x, and what is happening is there is an acceleration which is there on the opposite side. I hope that you are getting that point, because when you move this object from here to here, there is acceleration, that if you leave this object, then it will again come back to the mean position. This is what I am telling you. And at the extreme positions, the velocities are 0. That means that at this position, the velocity is 0. That at this position, velocity is 0. Similarly, at this position, my velocity is 0. Okay, these you have to keep in your mind. I hope that this is clear to you. Is it clear, my dear? That there is a mean position, and these points are known as amplitude point. These points are basically known as amplitude point, the maximum displacement what an object can take. These are basically the amplitudes. The positive amplitude and the negative amplitudes we are having. This is the mean position. O point is the mean position. Okay. This is basically a mean position. I hope that this thing is clear to you. And here, the first point is a condition for SHM, that the path must be a straight line. The first condition was for the path. The path must be a straight line. So yes, there is the path of this motion is a straight line. The next condition was that acceleration is always towards the fixed point. So here the acceleration is always towards a fixed point, and that is proportional to minus x of x. And I was also telling you that the force is also proportional to minus of x, that we will see later on. Time period is 12 hours for our end. Swaraj Kumar Das. Very good, Swaraj Kumar Das. So I hope that this example is clear to you. This is my first example, and I told you that in this chapter, basically my main focus was, my main approach is to give you an approach that once you started using these approaches, you will easily get the answers. So my approach is that you have to think in terms of examples and the equation. And my first example is the spring. And you can relate this spring with this very simple example, right? So there is a spring. If you stretch this spring and leave it, then what will happen? It will move to and fro. It will move to and fro. And this is the SHM what will be there, right? Similarly, to depict that SHM, what is happening at that point, I could say that from a mean position, from its natural length, that is the mean position, O point, from its mean position, this object will move from the extreme end to the other extreme ends, right? Suraj Kumar Das, is it clear, my dear, what is happening there? And now let's move toward the next point. There is a very simple terms what we will be using continuously in this chapter. The first term is time period. So my student, I have seen that student often gets confused that what is this time period and what is the frequency. The time period is that you are having a task to complete and how much time you will take to complete that one task. So I would say that to complete one task, one periodic task, which will again take the same time. So for to completing a one task, what is the time required, right? So you can say that the least time which you would take when you are completing one round. I could say that time required to complete. This is basically a time required complete one task. So here what is important is that my task is only one thing. My task is only one thing. Let me give you one example. Example is, if my heartbeat is, if for a normal person, the heartbeat is 72 times per minute. It's 72 times per minute. Now, in a minute, now think in terms of what I'm telling you. 72 times. The repetition of your heart is 72 times it is moving lup, dup, right? You must have studied it in the biology. So 72 times per minute, I can tell you that it means that 72 tasks are happening in 1 minute. Can you tell? Can you relate this thing that 72 tasks are happening in 1 minute? Or you could say that 60 seconds. Now I want a time period for a one task. So for a one task, I can say that it is equals to 60 divided by 72 seconds. So for me, my time period, will be equals to 60 divided by 72 seconds. That is my time period. And you can cut it using the multiplication table for 12, 12, 5, 12, 6. So you will get 5 divided by 6 seconds. I hope that this point is clear to you. And once this topic is clear, let me give you again a similar type of term which we often use in this chapter, and that term is known as frequency. That term is known as frequency. So what does this frequency means? Frequency means that for a fixed time, here what we are doing is for a fixed time, usually here 1 second we are fixing it. So for a fixed time, how many tasks is completed? For a fixed time, how many tasks is completed? Number of completed tasks. Very simple definition. Nobody will going to ask you the definition for the time period or the frequency. Just you need to remember that these are the things what we are basically calculating. So here let me explain you using the same example. If I'm having a heartbeat of 72 times per minute, which is, I think that it's an ideal heartbeat. So here you could say that you have to fix the time. I'm seeing here that in 1 minute, it's happening for the 72 times. So I could say that 72 times per minute could be the frequency, right? Or you can say that if you are fixing it for a 1 second, for 1 second, it's 72 divided by 60 hertz. Okay, so you will be getting 6 by 5 hertz. So for frequency here is 6 divided by 5 hertz per second is the unit what we need to write. And there is a relationship between frequency and time period. The time period is equals to 1 divided by f. So remember this thing also. The time period is equals to 1 divided by f. They are having basically an reciprocal relationship between them. I hope that this thing is clear to you. Is this thing clear? Please do let me know, guys. Fixed time, number of repetition, how many repetitions are going on. Suraj Kumar Das, Cyber and Science Creations, PG Raghul. Is this thing clear to you? Everyone, guys? Is this thing clear? Please do let me know. I hope that this thing is clear to you. Right? Shall we move? Using this thing, there is another thing what we will be extending. That is for a periodic function. You must have studied a periodic function in your functions and relations chapters of mathematics. So here, the periodic function, or a function to be periodic, there must be a time period that if we add that time period, we will get the same function. Okay, so here, if I'll add this time period, so here my t is the time period. This is my time period. Okay, and for some general functions, you must know that what is the time period. For some time period for some important functions. First one is sin theta. If anyone asks you that what is the time period for sin theta, here I am writing the function, and other than function, here I'll write a time period. I'll write function here, a time period here. Okay. For a sin theta, the time period is 2 pi. For a sin theta, the time period is 2 pi. You know why? Let me draw the sin theta graph for you. So graph of sine basically varies from +1 to -1. The graph of sine basically varies from so I can write here plus a minus a, or I'm writing sin theta here, so I can write +1 and -1. Okay, this graph is basically for sin theta. It starts from 0. The value here is 0, and at the peak point, the value is pi by 2. The angle is pi by 2. Here, the value is pi. Now, see the pattern. Here, the value will come out to be 3 pi by 2. Here, the value is 2 pi. Then, see here, pi by 2. At pi by 2, the value is +1. At 3 pi by 2, the value is -1. And at here, pi by 2, 3 pi by 2, here you will be getting 5 pi by 2. See, the odd numbers are coming here, 1, 3, 5. So at this point, I am getting 5 pi by 2. Similarly, at this point, I'll be getting 7 pi by 2. And if you go further, at this point, it will be 9 pi by 2. Okay, now pi, 2 pi, 3 pi, 4 pi, 5 pi. So this is how the sine theta goes and varies. So the when I'm telling you that this is the time period, what does this time period mean? This time period means that this value is repeating. All the data is coming again back. See, if I'm starting from here to here, I'm taking this as positive curve, this as negative curve. So you are seeing that once this positive cycle and negative cycle is over, again the positive cycle is coming back, but it is coming back after a time period of 2 pi. Again, after, if you add 2 pi again, you will be getting 4 pi, right? So this is how this is happening. So the time period for sine theta is 2 pi. Similarly, we are having a time period for a cos function. Similarly, we will be having a time period for a cos function. The time period for cos theta is 2 pi. Okay, now let's move. Time period for some common functions. So I was telling you that if the time period of sine theta is 2 pi, what will happen if there is another number, like if there is sine a theta, then what is the time period for that? Can you tell me that if there is sine a theta, then what is the time period for that? You let me know. The time period is 2 pi by a. The time period is 2 pi by a. And also we have omega is equals to theta by t. I can replace this theta with omega t, angular speed basically we are talking about. So if I'm writing sine omega t here, then the time period is 2 pi by omega. 2 pi by omega. Now if I'll write sine a omega t, my answer will be 2 pi a omega. So I hope that this point is clear to you. Similar thing will happen for a cos omega t, and similar thing will happen for a tan theta. Okay, now let's find out the time period for some other functions what we make could get. Can we do? Can we go for that? I'm giving you one thing, one extra tip for you. That if there is a function fx, which is basically a combination of one function, two function, and a three function, or so on so on. So basically this function is a combination of other functions. So what you need to do is you have to first, and if somebody asks you that what is the time period of this complete function, then to get the time period, get the time period t, for this, you have to take the LCM for the time period for this is t1, time period for this is t2, time period for this is t3. So what you need to do is you have to take the LCM, take the LCM of t1, t2, t3, and so on. Okay, let's solve some questions related to this. You have to find out the time period. Okay, find out the time period for this. Let me give you a few seconds to think. 1 minute is there. Tell me, what is the time period of this question? Yes, sir, it is clear. I joined late, so I started from first with 2x speed and we will end together. Okay, it's very fine. So working hard have given me the answer, correct. So sometimes I'm not able to understand when to differentiate and integrate in a question. Is there a simpler way to understand? Yes, it's a very simple thing. So the simplest idea is that when you are breaking the things, when you are breaking some big question into very small parts, you have to differentiate it. Think in terms of that there is a picture and I'm telling you that you have to draw that picture. You will say that, sir, I'm not an artist, I will not able to draw that, right? I will agree with you. Then I'll tell you that can you draw one cube or can you draw one square? You will say that, definitely you will say, if you try, you will say that, yes, sir, I would be able to draw. Then what is that pixel? What is that square? That is basically a pixel, right? So I'm always telling my student that in physics, sometimes you have to see only pixels. You have to divide the questions data into multiple parts, right? So whenever you are seeing the pixels, you have to differentiate, and when you are seeing the pictures, you have to integrate. This is the simplest approach. And other than that simpler approach, the other thing is that you have to remember the formulas, right? From the formula you will get that where you need to integrate and where you need to differentiate. So you first tell me that where you are getting that issue. Are you getting that issue in the kinematics question, that where you have to integrate or where you have to differentiate? For kinematics, basically we have a relationship between x, v and t. So you know that v is equals to dx divided by dt. And if I know that, that velocity is basically the rate of change of displacement, so I know that if I need to get this dx, if I need to get this x, I need to integrate this v dot dt, right? Similarly, you can get the graph between velocity and time, and you have to integrate that to get the displacement. This is how basically we approach this question. First of all, you must have a very strong basics to like understand this thing. Is it clear, my dear? And now tell me that what is the answer here. So how long will be the lecture you take, Krish? It would be around 2.5 to 3 hours. That is the ideal duration which I generally takes, because I want you to provide you a very concise theory, and then I'll be taking each and every questions from a JEE 2024. So this is basically the outline of the JEE main 2025 syllabus. In this, I have to complete the 7 topics. The first topic is already over now. The first topic was telling you that what is oscillation, what is periodic motion, and how we can calculate the time period and how we are going to calculate the frequency. So this is almost done. Now I'm telling you this periodic functions because this periodic function is also very important, as I have completed this time period. So that's why I moved to this periodic function. So this is basically going on now. And once this is over, I'll be moving towards the displacement and the kinematics of the SHM, because this is the simple harmonic motion and we have to study the motion. So whatever we have studied in the motion chapter, I'm going to relate those concepts in this chapter. I always tell you that once you are done with the basic mechanics, that is the kinematics, Newton's laws of motion, work, energy, and power, you are almost done with every concept being used in the physics. Now, after completing these three units, you need to do is to relate those concepts with the concept which I am teaching you. So here also, what we will do is we will study the kinematics of the SHM. We will study the displacement, acceleration, and the velocity. And once we are done with that thing, we will move towards the equation of the SHM, then the energy of the SHM, which comes from the work, energy, and power chapters. Then that is also the oscillation of a spring. It's just an example that there is a restoring force. So this chapter is very, very easy. If I'll classify this chapter being easy, tough, or hard, this chapter do not contain a lot of concepts, new concepts, I would say. This chapter is basically a relationship between whatever we have studied earlier. So I hope that you got the correct answer for this question. I already told you that how to approach the questions. So many times we have to do in the middle of the question, like we do in the kinematics or the electrostatic. Basically in kinematics, in electrostatic, if you will say that if you are very confused that where we have to integrate and where we have to differentiate, is that when we do not have the direct formula and we have the formula for a point objects, right? Like in the gravitation chapter, if I'm having a formula for the forces that only applicable to the point masses, then if I'm getting a extended object, that what is the best way to get the gravitational force in a I would say the continuous body, the best way is to integrate it, right? So this is what we generally do. I hope that this thing is clear to you. Let's solve this question and do let me know that what is the correct answer here. Do let me know that what is the correct answer here. I'll take a sip of water and you tell me 1 minute is over. Okay, so keep that thing in your mind. Whenever you are being limited by the formula, so what you need to do is you have to integrate it. And for differentiation, there are direct formulas generally. Maheshwari Bodu. And please do let me know that where are you from, what is your real name, because when you comes from that this working hard, Krish 36, Abhinav, you have to come with your real name, right? Your parents have given you a very good name, I think. So the time period for this is 2 pi divided by omega. The time period for this is 2 pi divided by 2 omega. The time period for this is 2 pi divided by 4 omega. You can write it as time period 2 pi divided by omega. Pi divided by omega. Pi divided by 2 omega. Now, to get the time period of the complete function, what we need to do is we have to take the LCM of all these time functions. And you know that how we can get the LCM of all these things? LCM is basically a multiplication table. LCM is basically a multiplication table, a common multiplication table of all these three numbers. So I can write that if this is my number, then this very next moment I'll be getting 4 pi omega. Next, I'll be getting 6 pi, 2 1 jar, 2 2 jar, 2 3. Okay, so on. Now for this, I'll be getting pi divided by omega, 2 pi by omega. So I'm getting that this is common, this is common, this is common, right? Now again for this, you will be having pi divided by 2 omega, pi by omega, then 3 pi with 2 omega, then 2 pi, divided by omega. Okay, so the LCM of this is basically 2 pi divided by omega. This is the time period what we will get from this question. I hope that this question is clear to you. Is this clear, my dear? Please do let me know. If this is clear, then we can move forward. Yes, working hard. So working hard, please do let me know what is your real name and where are you from. That is very important. Now let's find out the time period for sine square omega t. Now let's find out the time period for sine square omega t. Usually we avoid getting a direct formula for the square terms. So what I need to do is I have to convert this square into a linear function. So how I can do that is there is a formula for cos 2 theta. The formula is cos square theta minus sine square theta. You could replace this thing 1 minus sine square theta, that means 1 minus 2 sine square theta, right? So sine square theta will come out to be 1 minus cos 2 theta divided by 2. Okay, so this is going to be my formula which I'll be using for this thing. So now if I'll start this question, I could write this thing that sine square omega t will be equals to 1 minus cos 2 omega t. I'm keeping this thing and separate. Why I'm taking this thing as separate? Because this 1 by 2 do not having a time period, right? It do not contains the t. For that value, what will be the time period? Do let me know. What is the time period for this? Tell me, what is the time period? See, half do not have any value of for the time period. So my time period will be, it's 2 pi divided by 2 omega. This will be cut. My time period will be pi by omega. Okay. So if anybody asks you that what is the time period here, it's pi by omega. It's pi by omega. I hope that this thing is clear to you. Now let me give you one another question, and then we will move towards the next part. Now, what if I'll ask you that what is the time period of cos square to omega t? Cos square omega t. Can you solve that? Or sin q omega t? Can you solve that? Solve it for cos square omega t and let me know. Let me know that what is the time period for this cos square omega t. Do let me know. Pi by omega is very good, working hard, and you do not want to share your name, right? You let me know. Very simple. Similar steps will be copied. Try to solve it. The approach will remain same. You just need to think. Do not be a kid who do not want to try. You know how we can, you know what is the source of the energy? What is the real source of the energy? Some of you might think that food is the source of energy. It's not. Food is one of the source of energy, but food is not the source of the energy. The source of the energy is basically the motion. If you are in a motion, if you are in a hurry that you have to do it, you will get the energy. Have you feel that once in every religion there is a customs to have a fast where you would not eat anything for a few hours. You might feel some like lethargic, or you will feel that you are low in energy, but once few days are gone, you will feel again energetic, and you won't be like, your body will not be starving for the food, right? So the first and foremost thing what you need to do is you have to be moving. You have to type your answers. You have to like asking the questions from me, because this is how you can develop. And do not feel ashamed that when you do not get the answers, because when you are learning, you do not have to be shy. You do not have to feel ashamed that I'm not getting the answers, the others are getting the answers. It is the journey that you have to go through, right? Now, for this question, what we need to do is, again, I'm using this formula, cos square theta is equals to cos square theta minus of sine square theta. Now, I'll be replacing this value 1 minus cos square theta. So, I would be getting 2 cos square theta minus of 1, right? So, 2, 2, 2, 2, 2, 2, 2, basically cos 2 theta. So, I'm getting cos square theta. My answer will be cos square omega t will be equals to cos 2 omega t divided by 2 plus 1 by 2. So time period will remain same. My time period will be pi divided by omega. Okay, it won't get changed. I hope that this thing is clear to you. Can we move to the next part? No, it will be pi by omega. It won't be pi into omega. It will be pi by omega. I hope that this thing is clear. Right? Shall we move? Now. Now it's time to get the real motion. As we know that, what is SHM? SHM is basically a simple harmonic motion, right? SHM is basically a simple harmonic motion. And in motion, what was the first thing what we have studied? When I started the kinematics, the first thing was the frame of reference. And once frame of reference is done, I have discussed the distance and the displacement, right? Similarly here, when we are going to study the simple harmonic motion, when I am going to study the simple harmonic motion, we must be well acquainted with that what is the displacement here, what is the displacement in SHM. And to get the displacement in SHM equation, I could write it instantly, but I'm not writing it instantly for you. I'll be using a concept of projection of circle. I will be using a concept of projection of circle, and using that, you will get to know that how and why this equation is coming. So assume that there is a circle. In that circle, I am having a rod. In that circle, I am having a rod of the radius similar to the circle. So this is the O point center of the circle, and I am taking that the radius is A. The magnitude of the radius is A. Okay. Now, here I am having one thing. Here I am having one thing. Please be focused here. This is very, very important, and this is the ultimate thing what you need to understand. So let me here what I told you, that there is a circle, and in this circle I'm having a rod. Okay, a rod similar to this thing. I'm having a rod. I'm having a rod like this. So basically, this rod is moving in a circle. This rod is moving in a circle. Okay, and at one end, at this end, I'm basically having a light, and using this light, I'm getting a shadow of this road at this point. Okay, so at this location, at the similar position, I'm getting a point O here, which is the mean position. Are you getting that point? And what will happen if this object is being moved, or if this rod is getting moved to a different location at this point P? What will happen? And I'm considering that this angle, as this rod is moving with the speed of omega, and we know that theta, could write that omega is equals to theta by t. So this theta is equals to omega t. So you could replace this theta with omega t. Okay, so now if this is the light what we are projecting, then I can say that there will be a shadow at this point of this length. Can you tell this? And as this is in the y-axis, I will be writing this as y. If this is a, then what is this y? Y will be equals to a sine omega t. How many of you got this? That this y is equals to a sine omega t. How many of you got this? That there is a simple triangle. There is a simple triangle we are having. There is a simple triangle, and this is omega t. The theta is omega t. This is the hypotenuse we are having. And if I'll apply sine omega t, I'm keeping this as perpendicular. So sine omega t will be equals to perpendicular divided by hypotenuse. Then you will be getting a sine omega t. Simple trigonometry using a sine theta cos theta ratios. Okay. Similarly, if there is another light on the top of this setup, if there is a light at this position, and if I'm projecting this to this, I'll be getting that from this point O, this rod is getting a shadow. This is the P location, and as this is X, I'll be considering this as X, and this is X. This is Y. So your x will be a cos omega t. I hope that if that thing is clear, that thing will also be cleared, because this is the base. These are two fundamental, I would say, the fundamental displacement equation we can have with the SHM. And somebody could say that, sir, why the SHM is happening here? So once this rod is moving and I'm projecting, they see, you can see here, if this rod is like this, you will be seeing only a single point. If this rod has moved to this distance, you will be getting like you will be seeing some distance here. If this rod is in this position, you will be seeing the maximum distance. If this rod is in this position, you will again seeing that the distance is diminishing, right? So what happens here is that this, when this rod is moving in this direction, when this rod is moving in anti-clockwise direction, this distance will get increased, and this will get increased till this point. And after that, it will again decrease, because if this rod moves to this point, then it decreases. Then again, if it reaches this point, it gets to this position, right? And again it moves. So basically what it does is it moves top position, then low position, top position, then low position. So basically what is happening here is SHM is there. I hope that this point is clear. Okay, similarly here also you will be seeing that the SHM is moving from plus A to minus A. You can consider this as plus A and you can consider this as minus A. So this is what is happening here. Similarly here, you could mark this as plus A and this as minus A. So from plus A to minus A, this SHM is happening. So for the displacement equation, displacement in SHM, I could either consider this y is equals to A sine omega t, or I can consider this A sine omega t. So for a simplicity, I'm telling you that I'll be taking y sine omega t, or if there is a phase difference, I'll be considering the phase difference as well. There is, that will become sine omega t plus phi. That phi is basically the initial phase, the starting position. Or you could write this as A cos omega t, or A cos omega t plus phi. Okay, this phi is the initial phase. So this is the displacement equation we have in the SHM. Okay, I hope that this displacement equation is clear to you. Now let's consider the initial phase. Is it clear? I am from Assam, Tribhumi, near Bangladesh border. Okay, Suraj Kumar Das, it's great to see students coming from the Assam border. Bangladesh, Assam and Bangladesh. Yes, Guwahati is very near to Bangladesh. Okay, I'm having a map here to know that from which part of the country the students are coming. Great to see you. Shall we move? Shall we move? Shall we move? If this thing is clear, I can say that something is going in your mind. And if this thing is not clear, then please do let me know, because this is very important. Clear? Okay. Now, if this thing is clear, I'll be considering only few equation, because we are in a learning situation. For in a learning situation, what we need to do is, first we need to clear all our concepts using a particular equation. And when the question comes using the different equation, like if the question comes from the cos omega t plus phi, we know that how to approach the question, right? The first thing what you need to do is to get the correct approach. So telling you the kinematics of SHM. To get the kinematics of SHM, the first thing was the displacement. I told you that the displacement is equals to, you can write it either in x or y. I'm taking a standard equation that x is equals to a sine omega t. Okay. Now, what if you need to find out the velocity? So if somebody asks you the velocity, you know that velocity is nothing but a differentiation of the displacement functions we are having, right? So you need to differentiate this, and once you differentiate this, you will be getting a omega cos omega t. The differentiation of sine omega t is cos omega t. And again, if somebody asks you that what is, okay, sometimes we have to get a different formula as well for the velocity. So velocity, I can write this as a omega. For this cos omega t, you can write this as 1 minus sine square omega t. Can you write this? Right? You can. And you can replace this v a omega. You can replace this using this thing. Sine omega t will be x divided by a. So you can write this as x square minus a square. So that will become v is equals to a omega under root a square minus of x square, right? And this will not be there. So this is also a velocity formula. This is our displacement equation, and this is the velocity. Okay. Now, somebody can ask you that what is the maximum velocity? What is the maximum velocity value? For a maximum velocity, we know that the particle must be for a, let me draw the diagram for you, the example which we were taking. The example is very simple, that the object starts from O point and it moves towards the plus A, and then again it moves towards the O, and then again it goes to minus A, and then again come back to the O position, right? This is basically what we are having. So here, what is happening? Somebody is asking me that where does this SHM is having the maximum velocity. So I know that this point, at this point, we are having the maximum velocity, right? Vmax. So for Vmax, the x is equals to 0. Here the x is equals to plus a. At this position, you are getting velocity as 0. And at this position also, you are getting velocity as 0. Why? Because at this position, the object gets stopped. When this object is moving, at the extreme points, this object gets stopped. And when this object gets stopped, the velocity is 0, right? So to get the maximum velocity, you need to put the value of x as 0. So you will get that Vmax is equals to omega a. This is also a very, very important formula which you need to remember. And you will see that using these simple concepts, we will be able to solve the difficult questions as well. I hope that this is clear to you. And now let's move towards the acceleration part. We are done with displacement velocity, and we know that there is also another term what we need to learn if we have to complete our kinematics for the SHM. The third part is the acceleration. The third part is the acceleration. So for getting the acceleration is basically the differentiation of the velocity function. So here I am having a velocity function. So if you differentiate it again, you will be getting minus a omega square sine omega t, and you can replace this a sine omega t with the x, so you will get minus omega square x. So this is basically the value of acceleration for SHM. Is it clear, my dear? And once this acceleration is there, you can easily find out the time period. Sir, what we should do after attending your lecture? Can you please make a timetable video for us who are following you? Yeah, sure. Basically, once you are done with this video, what you need to do is download the PDF from the Telegram group and then revise it. Within 10 minutes, you will be able to revise this PDF, right? I've already, that you have attended this lecture live, so you do not need to take a lot of time for this revising. You have to revise this, and once this revision is done, I am uploading a practice paper that contains only 20 questions. You have to do that, and once you are done with that practice questions, you can go for JEE PYQs. Okay, so I do not recommend you to do multiple things, but because if you follow this simple strategy, because the time is very limited, right? Your paper, you hardly have 40 to 45 days. So you have to follow a very simple strategy so that you will be able to complete a lot of syllabus with a basic knowledge, so that you can attempt, like if some questions comes very easy, you can attempt it very instantly, right? So I want you to do multiple set of topics. So once this topic is done, you have to revise this and then solve my practice paper, and after that solve the previous year questions. I hope that this thing is clear to you. Is this thing clear? Is kinematics of this thing is clear to you? Do let me know. And if this thing is clear, there is another important scenario what you need to learn. I hope that this thing is clear, right? Suraj Kumar Das. Yes. And please share this session with your friends, because when you come, that motivates me to take better questions in this class, in another class, right? And it motivates me to give you the best content which I can have. Next thing is equation of SHM. Equation of SHM. We will do the questions for based on what we have studied, the kinematics, but we will do it later on. So you know that for there is a condition for SHM that there must be a restoring force. The force must be, if the force is restoring, it could be in this format: force is equals to minus of kx, and there is a graph. What you need to learn, this is known as SHM graph between force and x. The graph seems to be like this. Okay. Now force must be minus of kx for SHM, and force is equals to mass into acceleration. This we know. You can use this m d square x dt square using the second law of motion, right? Now combining this, you can do from 1 and 2. From 1 and 2, we get m d square x dt square plus kx is equals to 0. Okay, now d square x dt square plus k by m x is equals to 0, and d square x dt square plus omega square x is equals to 0. Okay, and if this is our equation, you can write that omega is equals to under root k by m, and time period is equals to 2 pi by omega. So time period is equals to 2 pi under root m by k. And this formula is very easy to remember, because when you are studying with Manoj Kumar Sir, this formula is very easy to remember. Just you need to do is remember my name. My name is Manoj Kumar, and you are studying from Manoj Kumar Sir. So what you need to do is just remember my name. And if you remember my name, the chapter SHM will be very easy for you. So you just have to remember that you have to keep the mass here and divide it by k. You will get the time period. Is it clear, my dear? To get the time period, it's very, very easy. Now let's move towards the question. Shall we? Shall we move towards the question? So let's see that which type of questions might come. Let me first give you this question. This question is very, very basic, and this question is directly from the NCRT. This question is to give you the basic idea and the visualization to have to solve the real questions, because once we move from this topic to another topic, I have taken the real questions from JEE Mains 2024. So here you'll be getting the so many questions out there based on real exams. So let's first solve this thing. Here a particle is in linear SHM. So here the particle is in linear SHM. Between 2 points, there are 2 points, A and B. Okay, so there are 2 points, A and B. So there are 2 points, A and B, 10 centimeter apart. Take the direction from A to B as positive, and give the sign of velocity and acceleration. So I know that this particle is moving from this to this point. So I could take one thing. Why to take this? I can consider a point O here, and from here to here I could write this as plus 5 centimeter and this as minus 5 centimeter. Are you able to get it, that why I'm writing this minus 5 centimeter and plus 5 centimeter? Just to know that these points are like separated by 10 centimeter and there is SHM happening in between. So now you have to mark the direction. You have to keep the, basically in this question you have to give the sign for the velocity, acceleration and the force. Velocity, acceleration and the force, you have to give the sign. So for A, please let me know at the end A, if the particle is at end A, that means at this point, what is the velocity at this point? The velocity at this point is 0. So I could write that velocity is equals to 0, right? And if the velocity is 0, please let me know that what is the acceleration at this point. Please let me know that what is the acceleration at this point. Swaraj Kumar Das, please let me know that what is the acceleration at that point. At end A, at this point, I'm telling you that velocity is 0. At end B, I'm considering both these questions together. Velocity is 0 here. So you have to tell me that what is the acceleration here. You know what is the acceleration formula? You have to think in terms of formula. Generally, what students do is they started feeling the question, and when they started feeling the question, they committed mistake. You have to think in terms of formula. Think in terms of formula. And if you think the formula is acceleration is equals to minus of omega square x, or I could say that acceleration is proportional to minus of x. Similarly, your force is basically mass into acceleration. So you could say that that is only that force is also proportional to minus of kx. I could write this thing as, so if you are moving in a negative direction, this is the negative side, right? This is the negative side and this is the positive side. So if you are at the negative side, then what is the value of acceleration? So acceleration will be positive or negative? Do let me know. Here x is maximum acceleration, velocity is 0 but acceleration is positive, force is positive. Here acceleration is negative, force is negative, because it's at the positive side. So when the value of x is positive, so if I'm at the positive side, the value of x is what? Positive. So if I'm putting the value of x as positive, I'll be getting acceleration as negative. But what if I'm putting the value of x as negative? I'll be getting the force and the acceleration as positive. You just need to think in terms of formula, right? So you just need to think in terms of formula. Now, at the midpoint, now do not, if you got this a first and second, try to apply this thing in the third part. At the midpoint of AB, you are at this point. You are at this point. So at this point, what is the value of velocity and going towards A? You are going towards A. That means that you are moving towards A, right? So tell me, if you are moving towards A, what is the value of V? You are moving in the negative direction, right? You are moving in a negative direction because this direction is positive, this direction is positive. See, there is an axis, right? This is basically an axis. So if you are moving in this direction, this is positive. If you are moving in this direction, this is negative for the velocity. So my velocity will be negative and your acceleration will be 0, because at this point this x is equals to 0, and if you substitute the value of x as 0, you will get the acceleration as 0, and similarly the force will be equals to 0. Are you getting that point? And now let's move towards this point at 2 centimeter away from B, going towards A. So you are at, because the distance between this and this is 5 centimeter. So you are at this point 2 centimeter away. I'll be taking this as D point. So you are at this point and you are moving towards A. So you are moving towards A. So your velocity will be negative. Your acceleration will be negative. Your force will be negative. Are you getting this point? Are you getting this point? Both are negative, all are negative. All negative. Now at 3 centimeter away from A, but moving towards B. So you are at this point. So for this point, my velocity is positive, acceleration is positive, and force is also positive. Force is also positive. That means all are positive here. Now let's move towards the next part. At 4 centimeter away from B, going towards A. At 4 centimeter away from B and going towards A. That means you are at this point F. So I think that it's similar to the A, similar to the F. All are negative, right? All negative. All negative. I hope that this question is clear to you. Is this question clear to you, my guys? Jasmeet Kaur, got it? Jasmeen Kaur, where are you from? Suraj Kumar Das, is it clear? Clear. Done. Can we move now? Okay. Now, let me show you that how much is done in this today's class. How much is done? See, we have started with the very basic thing, the time period, and we have started with this topic, oscillation. What is the oscillation motion? What is the basic difference between the periodic motion and the oscillation motion, and how we are going to calculate the time period frequency? Okay, we have started with this. I've already discussed this displacement as a function of time. We have discussed this periodic motion, and I have discussed the simple harmonic motion equations and its phase. Okay, so let me first give you some questions related to this. Then we will move towards the oscillation of a spring, energy in SHM, and the derivation for expression for its time period. That if you are getting a simple pendulum, or you are getting any type of SHM, there is multiple situations in which you will get the SHM. Then how you will going to find out the time period, because this is the ultimate thing and the takeaway from this chapter, what you need to learn, because this is only what you have to apply in the other chapter, right, to get the time period. So these 4 topics are done, only these 3 topics are left, so we will complete this in this lecture only. Let me give you one question. Are you able to get all these things? Is it clear, my dear? I'll be covering each and every topic. Only 3 topics are left, and once these topics are covered, we will be solving the JEE PYQs. Okay, I hope that you all are agreeing with the fact. Okay, now there is a displacement equation given to us. That x is equals to 5 sine 20t plus pi by 3. Okay, this is the displacement equation what we are having. And tell me that at what time the object first comes to rest. Okay, when does the particle first comes to rest? This is the question. When does the particle first comes to rest? When does the particle first comes to rest? You know, this is basically an equation of a displacement, but here I am seeing a phase difference. What does it mean? It means that I already told you that the simplest approach of solving the SHM question is to relate this with an example. And I have only told you one simple example, which is this. I've only discussed one type of example, right? Where is my example? Yes, this is my example. I have only discussed this example, so we have to use this example only. Where is my example? Yes, now you know that for motion to be SHM, the object is basically starting from this point O, and it will goes to the plus A to minus A again. But this is basically starting from plus pi by 3. What is pi by 3? If you have any confusion, then replace this pi with 180 divided by 3. So this is basically a 60 degree. Okay, so we are at 60 degree. So this position is 60 degree. So my object is moving from this position. And I know that the object comes to rest for the first time. The object comes to rest for the first time here. Isn't it? The object first time comes to rest at this position. So I can do one thing. Are you able to get this? What I am telling you? At t is equals to 0. At t is equals to 0 second, when the motion is starting, this object is at this location. This motion is basically starting from this initial position. That's why we are having a plus pi by 3. This is the phase difference what we are having here. And the first time this object is coming to rest is at the extreme location, at the extreme amplitude. And using this equation, I can substitute, or I can use that at this. What is the value of this? 5. So I can say that 5 is equals to 5 sine 20t plus pi by 3. How many of you are getting? This will get cut this, and sine 1. I can use this pi by 2, sine pi by 2 is equals to sine 20t plus pi by 3. Are you getting my point? Okay, now you just have to solve it. The approach is clear, and you know that once the approach is clear and you are well prepared, and you know that these are the patterns of questions which might come in your exam, then you can solve these questions within few seconds. because the moment you see the questions, you will know the approach, and if you know the approach, you will able to crack this question. So here, what I am going to do is, I can replace this sign. So I can write this pi by 2 minus pi by 3 is equals to 20t. So that going to be a 6 pi by 6 20t, and my value of t will be equals to pi divided by 120 seconds. So after this much of time, this value is getting 0. I hope that this question is clear to you. Is it clear, my dear? Please do let me know. Is it clear, my dear? Huh? Okay. Now, if I'll ask you in the same question, if I'll ask you in the same question, when can, when does the particle have zero acceleration? When does the particle have zero acceleration? Can you find out? This is my A part, and I'm telling you that there is another B part. When does the particle first comes to rest, and when does the particle first have zero acceleration? Okay. When does the particle first have zero acceleration? This is, you need to find out. Please do let me know how we are going to approach. Our examples remain same. I already told you that we have to think in terms of the example to get the answers correctly and immediately. So once the object is at rest, the position was this, but to get the acceleration to be 0, now you tell me where we can get the acceleration to be 0. Acceleration will be 0 at our mean position. At this point, acceleration is 0. At this point, acceleration is 0. Isn't it? Tell me. Acceleration is 0 at what point? Center, right? Suraj, working hard. Yes. Acceleration is 0 at the center point. So what you need to do is, you have to put x as 0. And if you put x as 0, you will be getting 5 sine 20t plus pi by 3 is equals to 0. So that means sine 0. But you would not take sine as 0, because sine 0 is at that point. Then at this point, it is pi by 2. And at again this point, that will be pi. So I have to take this as sine pi. Are you able to understand that why I am taking sine pi here and not sine 0? Because this object is already been there, and again it will come back to 0 at sine pi. So I can take this as sine pi, and you can take this as 20t plus pi by 3 is equals to pi. Just replace this thing. 20t is equals to pi minus of pi by 3. You will get 2 pi by 3. And you will get t is equals to pi by 30. Pi by 30 seconds. So this is what you will get. So by timetable, I mean the time slot as given in the study time, very less, but I'm ready for hard work. So, okay, the timetable, basically, I'll tell you. See, the one shot, or I could say a quick revision lectures on our YouTube channel. The time period is from 5 p.m. onwards, right? 5 p.m. to you could say I'm taking for 3 hours. Nabamita ma'am and Bhumika ma'am, I think that they are taking for 4 to 5 hours. So you can say that from 5 p.m. to keep time period to 9 p.m. Okay. From 5 p.m. to 9 p.m. you can have this thing. Take a rest, and after that rest, attempt PYQ. Okay, chapter wise PYQ is there because we are completing one chapter only, right? So you have to attempt PYQ and at least solve 5 years PYQs. In my session, I always try to complete JEE 2024 and 2023 PYQs. If there are so many questions, then what I do is I try to complete at least 1 year. So you will be left with only 4 years. That is one of my tasks, what I'll be doing. You have to do at least 5 years PYQs. And I'm telling you, 2024, 2023, right? 2017, 2018, and 2020. I have selected these questions consciously. 2020 because this is before Corona hits. And other than that, you have to do this thing, right? So these are very, very important set of previous year. What you need to do is, third thing is, you have to revise these many things because time is very limited. You can do only these things, right? Only these two things will give you more confidence, because if you see the latest pattern, you will see that similar type of questions are repeating again and again. And when you are solving questions, do not go for the data. When you are solving any question, what is important is the question is not important. When you are solving any question, look for pattern, look for formula that is repeating again and again. Look for pattern, because there is some pattern in 2024 and 2023. You will see that, you will feel that. That's why the cutoff is increasing. You will see that in 2024 there were around 60 to 70% of questions which is directly similar to the kind of PYQs what we were having in 2023 or previous to those. So if you are well versed with these PYQs and you know the pattern, the formula which is there, look for the pattern and target and write the formula. Look for the pattern and write the formula, which is very, very important, because sometimes it happens that you will be seeing that a similar type of formula is being used in 2024 and 2023. So that means that you have to do that formula, you have to remember that formula. Only 45 to 50 days are left, so you cannot miss those formulas, right? Those formulas are very, very important. And even if you feel that remembering those formulas are very difficult, I would recommend that please write that in the notebook and try to remember that in every night, or after every 2 days, or just before the exam, at least revise that. Okay, look for the pattern, recognize, improve your speed, because speed is very important. Generally, I felt that in January attempt, students knows that how to approach the question, because when they are watching the videos, they know that that this is the correct approach, but they are not able to deliver that in the real exam. So what you need to do is you have to improve your speed. Look for the unit digit, look for the dimensions, and try to see the, I would say that, options whatever being given to you, because you have to ultimately choose the correct answer, right? So it's not about solving the question, it's about choosing the correct answer. So when you get the correct answers, you will get the marks. So you have to improve your speed. To improve that speed, there are so many things what you could do. The first and foremost is to improve your calculations. You can do it using the like, there are mental maths calculations for that. You can use the unitary method, unit digit method. So there are so many things. If you face any issues regarding the improvement of speed, I will take a separate session for that, because it is ultimately a different kind of approach what I'll teach you, that to get the correct answers. First you need to do this thing. This is your base. So make your base strong. This is your base, and this is your that you have to make your base strong, because I'm a kind of a teacher who wants to deliver maximum things in a very limited time. So I'm taking only 3 hours lectures, but that 3-hour lectures is like I'll be giving you everything in a bullet points, like you have to do only these things in these types of question, this thing in this type of questions, and I'm solving the previous year question as well, right? In my all lectures you will be getting that at least 2023 and 2024 questions are there in every sessions what I'm taking. Top 5 topics in physics class 11th, I'll share a separate video for that. Okay, please join our Telegram group. You will get the video there. Shall we move? Shall we move now? Okay. Now, I already told you that there are some. Yes. So now we are done with these 4 topics. Now it's time to get a basic knowledge about the energy in SHM, that how the kinetic energy and the potential energy in SHM works, and then we will move towards the simple pendulum and how the simple pendulum works. And once we are done with all these concepts, we will move towards the JEE PYQs 2024. Okay. I hope that this sounds good to you. Is it? Is it, my dear? Let's understand. Okay. Now, let us talk about the energy. I told you earlier as well, the simplest example of the SHM is the spring example. The first thing is to get the potential energy of a spring. Potential energy, I would be saying. So potential energy is half kx square, right? Half kx square. And this is the, uh, basically you can say that this is the energy which I could say, I could take. And also we know that, k, we have discussed the equation of SHM, right? This k is equals to, if you need to find out the value of k, how could you get the k? K will be equals to m omega square, right? If I need to find out k, that k is equals to m omega square. So you can replace this. That potential energy is equals to half m omega square x square. Okay. So remember this thing. This is very, very important formula. And there is a particular graph for a kinetic energy. Kinetic energy is half mv square. And you know that we have calculated the v as well. Where is our v? V is here. So we have calculated our v. This is our v. Take this v. We know that v is this thing. So put this v here. Kinetic energy is equals to half m v square. That means omega square a square minus of x square. This is our kinetic energy. And if somebody asks you that what is the total energy, and if somebody asks you that what is the total energy, then you can write total energy T is equals to PE plus KE. And you can write this thing as total energy is equals to half m omega square a square. Okay. Now, I'm taking one very basic example, that there is a spring of mass m, and it is doing a SHM from this minus a plus a. Okay, this is moving again and again. Now, if you have to draw a graph, if you have to draw a graph if you have to draw the graph between the potential energy and the x, you know what potential energy is maximum at this point, lowest at this point. This is my potential energy and this is x. Similarly, if somebody tells you that you have to draw a graph, you have to draw a graph between kinetic energy and x. This is kinetic energy, this is x, and your graph will look like this. Kinetic energy is maximum at what point? Kinetic energy is maximum at mean position. And there is a special technique if you are being provided by a graph. I always tell to my student that you have to think in terms of the formula. You have to see only the extreme ends if you do not have any plan. See, if you do not have any plan, just search for the extreme ends. That we know that at the extreme ends, what does it mean by the extreme points? Extreme points means that if this object is at O point, that means if this object is at mean position, there is no potential energy at all. So I know that potential energy will be 0 at this point. But for the kinetic energy, if this object is moving, the kinetic energy will be having the maximum value, right? So this is what you need to know. And the frequency of, if the frequency of kinetic energy is basically twice of frequency of SHM we are having. Frequency of kinetic energy is equals to twice the frequency of SHM we are having. Similarly, the frequency of potential energy is equals to twice of frequency of SHM we are having. Okay, so I hope that this thing is clear to you. Very, very important, right? Let me take another example. This is all about energy. Energy is very simple. See, energy is very simple. Energy is all about that capacity of doing work. And generally, the most important factor is that we have to only study the mechanical form of energy. And in the mechanical form of energy, we are having only two types of energy: the potential energy and the kinetic energy. Kinetic energy is such a sweet form of energy that do not get changed in any topic. A very simple formula we are having, half mv square. So we know that the velocity of the SHM, just we need to place the that value, right? Now it's about a combination of a spring. You know what is spring? A spring provides a restoring force. What does spring do? Spring provides a restoring force. So anywhere where you want the object to being restored at the position, at a particular position, or at a position where we want that thing, we use springs. Springs we use in cycle, right? Springs we use in soakers, springs we use in our pen. There are so many things in which we use spring. You cannot imagine, like we do not have the replacement of the spring yet, right? There are so many advancement in the I would say electronics era or the computer era, but there is no advancement at all in the mechanics or the mechanical engineering. Spring is an integral part of the mechanics. Spring we use at multiple locations, like even in bed, in the sofa we have the springs. Even in the doors we use springs, right? Even in the chairs, what we have, chairs which can go back and again it comes back, there also we use springs. So springs are everywhere. The type of spring could get changed, but spring is everywhere, right? So spring basically provides a restoring force, no matter whether you are stretching it or you are compressing it. The spring will provide a restoring force that is equals to minus of kx. Kx means the displacement from the mean position, right? It is to provide the restoring force. Now, there is a combination of spring which you need to know. For a combination of spring, there is a series combination that if there are multiple spring constant, the spring constant k1, k2, k3, and you need to find out k equivalent. So 1 by k equivalent will be equals to 1 by k1, 1 by k2 plus 1 by k3. It will be very easy to stretch a spring in a series format. So if the springs are attached in series, you just need to add them up like you do in resistance when they are connected in parallel, right? So hammer laker, what, Rocky bhai? Is I'm looking like a Rocky bhai or I'm looking like a Pushpa? Is I'm looking like a Rocky bhai or I'm looking like a Pushpa? See, I'm having a gun. But you have to learn, right? If you do not learn, I am having this rod with me, right? See, I can change this rod to Pushpa like style. I can use this rod as a Rocky Bhai style. So I have multiple styles. See here. Now, if they are connected in parallel, K1, K2. So K equivalent will be equals to K1 plus K2. K1 will be equals to K1 plus K2. Okay. So this is a very simple example for a time period we are having. Okay. I hope that this thing is clear to you. Is this thing clear, my dear? Spring is used to measure weight. Yes, correct. Spring is used to measure weight as well. Okay. Now, you have to find the time period. There is a block of mass m, spring constant k1, k2, and we have stretched this spring, and then we have stretched this spring to a distance x, and then we left it. What is the time period here? So you know that time period, to get the time period in simple harmonic motion is very easy, because you know that you have studied from Manoj Kumar sir, and the time period formula is 2 pi. The time period formula is 2 pi under root Manoj Kumar sir, mk, right? So this is the time period. But the difference is that here what we need to do is we have to place the k equivalent. We have to place the k equivalent here. So these are connected in parallel. These are connected in what? Parallel, right? So for a parallel combination, what you need to do is you can get it 2 pi under root m divided by k1 plus k2. Are you getting my point? Are you getting my point? Now, what what if this happens? This is K1, this is K2. What will happen? Do let me know. What will happen? If this is the case, then what will happen? So put the effort on your study. Thank you. Thank you, Shruti Yadav. Where are you from, Shruti? There will be minus, I think. No, minus will not be there. Plus only. Plus only. Okay. Now, here also, they are also similar effect we will be getting. Why? Because if you move this object by a very small distance, let me tell you that if you move this object by a distance x, then what will happen? This the left hand spring or the right hand spring, both will be applying the force the same direction. This right hand side spring will also apply force in this direction. Similarly, this left hand side spring will also apply force in this direction, right? So you will be getting the same time period here, 2 pi under root m by divided by k, k1 plus k2, the same time period you'll be getting. Okay. Now the next thing is, what if you are having this type of setup, k1 and k2? Here your time period will be 2 pi under root m. Now tell me. Now you know that k equivalent will be equals to 1 upon k equivalent will be equals to 1 by k1 plus 1 by k2, and that will be equals to k1 k2, k1 plus k2. So you can write k1 k2, k1 plus k2. This will be my answer. Okay, Suraj, I hope that this thing is clear. Clear. Okay. Okay, now if this thing is clear, now before moving further, let me first the simple pendulum or an angular momentum, angular SHM. For angular SHM, time period will be equals to 2 pi under root. For in place of mass, what I could do is I can replace the mass with the moment of inertia, right? I can replace the moment of inertia. I can replace the mass with the moment of inertia, and here it will be k, right? And for a simple pendulum, what we usually study, there is a mass m, length l, and it moves to this point. Then we know what the time period for this is, 2 pi under root l divided by g. 2 pi under root l divided by g. Okay. Now there are some conditions which you need to remember. there are some conditions which you need to remember. First of all, I could write that this is basically the net acceleration we could have. No, Shruti Yadav, I do not see Big Boss, because in Big Boss you will find like there was a. I would not want to tell you. Okay, now now there is a pattern of questions which might come in your exam. So the important pattern is there are some important cases. First one is the lift. So in the lift case, the lift could be at rest. When the lift is at rest, when the lift is at rest, then what could happen? The time period will be equals to 2 pi under root L by G. Now, if the lift is moving upward, if the lift is moving upward, I'm considering that this lift is moving upward with an acceleration A. And if this lift is moving upward with an acceleration A, the time period will be equals to 2 pi under root L divided by, you tell me that whether the time period will increase or decrease. And if this is moving in the downward direction, with an acceleration A, you tell me that what is the time period here? Will increase or decrease? We have already done this. That whenever you are moving upward, whenever you are moving upward, the acceleration will increase, right? So you could write this as G plus A, and here you could write this as G minus A. In free fall conditions, the time period is infinity. In free fall, time period is equals to infinity. Okay. Now this was a lift case. Similarly, you are having a case where there is a horizontal acceleration. I hope that this case is clear. I was talking about total time period. Tanmay Singh. Okay. Okay, good. Now, second one, when there is moving forward with, yeah, moving horizontal with A acceleration. So consider that you are having a vehicle, and in that vehicle, basically, you are taking one simple pendulum with you, and what will happen to the time period? There is a simple pendulum, and this vehicle is moving with a constant acceleration a. Then the time period in this scenario is 2 pi under root L. You know what will be the acceleration here? The acceleration, as we know that acceleration due to gravity is always downward, and acceleration due to this thing is here. So your net acceleration will be under root a square plus g square. So you have to substitute this value. You have to substitute this value here. So you will get under root a square plus g square. I hope that this point is clear to you. These are very, very important points that you have to remember. You will get different case. Okay. I hope that this thing is clear. And even it can happen that if this object is rotating, what will happen if this object is rotating? If I'm telling you that this object is rotating, if this object is rotating, you have to consider if there is circular motion, the A net will become centripetal force acceleration plus g square. Okay, and centripetal, you know, it's equals to v square divided by r. So this is how we solve this question. Wait a minute, I'll check my battery, and do let me know that is this thing is clear to you or not. We can then proceed with the numericals. I hope that this section is clear to you. Shruti Yadav, where are you from? And are you a girl or a boy? Suraj, Tanmay Singh, please do let me know that where are you from, guys? Where are you from? Shall we go? Now, I told you that we have to do these many topics. I told you that we have to complete these many topics. We are done with the oscillation and periodic motion. I've also discussed the time period and the frequency, displacement as a function of time, velocity as a function of time, acceleration as a function of time. We have done with this. So periodic motions, periodic functions is done. Simple harmonic motion and its equation is done. Oscillation of a spring, restoring force and the force constant is also done. So energy, we have completed this. Kinetic energy and the potential energy we have to study. Simple pendulum, derivation of expression. Basically, we are not concerned with the derivation. When we have to derive the time period, what is the basic thing what we need to do is we have to either find out the acceleration or the force, and then we have to relate the equation with the normal SHM equation, and then we can find out the time period. Okay. There are some few examples in the HC Verma where you will see that you have to find out the time period, where you have to find out the time period of a basically when you are when you are pushing any object in a fluid or in gravitation. There are some questions which you have to do. Okay, now let's solve some real JEE exam questions. This question is from 24th January, shift 1, 2024. You have to solve this question. Do let me know what is, can we have complete phase of SHM? Complete phase means what? Complete phase means what? No, I know about you, that you are from Assam. I'm asking for the other person. Can we have completed phase of SHM? Means what? What are you asking? I'm not clear with your question. Yes. Tell me, what is the answer? Tell me, what is the answer? I'm giving you. Question is from 2023, not from 2024. Let me know. Phase of SHM means you are asking about this thing. This phase. Phase we have already done, right? We have done this question. Where was where was that question? In this question, right? This is the phase. Initial phase. Phase is nothing but just tell you that how we are, like, this is the initial phase, and the total angle what is there in this equation is known as phase. This is the total angle which is known as phase, and this is the initial phase we are having. So phase is already done. When we are done with the equation, that means that phase is also completed, right? Spring K, see here, springs of spring constant. Spring constant is already given to you. That is the K. You need to know. It will not be giving you explicitly that this is the K, right? You have to understand this from the question. This question is from JEE 2023. This question is from JEE 2023, and you need to find out this answer. So block of mass m is there, is attached to two identical spring constant. This is K, this is K, and I have discussed this question, right? See, I have discussed this question here. Similar to this, right? Similar to this, we know that time period is 2 pi under root m by k plus k1 plus k2. K1 plus k2. So you can write this, that time period will be equals to 2 pi under root m divided by 2k, because both of them are having a spring constant k. Now the block is placed on a frictionless surface and the ends of the springs are attached to the rigid support. When the mass is displaced from its equilibrium position, it executes SHM. The time period of the SHM is this much, and you have to find out the value of x. So it's very simple question, I would say. It's very simple. Please let me know what is the answer. Very simple question, I would say. Tell me the answer. This is numerical type question. Yeah, you would not get the options here. You have to tell me. I've already given you the formula, the direct formula, and it's from our notes only. Isn't it? It's from our notes. Tell me. Suraj Kumar Das, Krish. Krish, thank you. Arey, I have already discussed this pattern. I've told you that how to get the time period, and for getting the time period in SHM is very easy because you know that my name is Manoj Kumar. My name is Manoj Kumar, and you can easily remember this formula because the time period formula is 2 pi under root m by k. So m stands for Manoj and k for Kumar. You have to get the k equivalent, and in this scenario, the k equivalent is 2k, right? So this is the formula. Mass is already given to you. Just replace this 2 pi under root 2 divided by 40. 2, we're getting under root 20, right? So you can do one thing. You can take this pi, take this 2 again inside this root. So you'll be getting 4 divided by 20, 1, 5. So it will be 5 pi divided by root 5. So see, we have to compare this value with this value. So by comparison, I can say that my x is equals to 5. So you have to write 5 in the answer because this is a numerical type question. 5 is correct. Yes, 5 is correct. Now let's move. See, whenever we are solving the real examination question, you do not need to see that what is the question. You have to see that which type, like how they are modifying it. So this is a modified version because this question is from the NCRT and SC Verma. You will get the same question, similar type of question you will get in the NCRT solved example. Also in SC Verma, there is a similar type of question. So it's not altogether a like question out of the league. But the speciality of this question is that they are asking you a time period in which you have to modify it to get the correct answer, right? You are not getting it directly, right? Just you put the solution, just you put the values and you will get the answer. It's not like that. You have to modify it accordingly. Now let's move to the next question. In this, a body of mass 200 gram is tied to a spring of a spring constant given to us, while the other end of the spring is fixed at this. If the body moves about O in a circular path on a smooth horizontal surface, okay, there is a horizontal surface, and in this horizontal surface, basically what you are doing is you are rotating an object here in a circle. Okay, so this is what is happening here. So omega is already being provided to you, that the omega is 5 radian per second square per second. Then the ratio of extension in the spring to its natural length will be what it could be. You have to tell me. Now, what will be your approach? What will be your approach in this question? How you could, can you please do a session of JEE rotational motion PYQs? Rotational motion, I think that we have already completed. I have divided rotational motion into two parts, the part 1 and the part 2. And in that session, also we have completed the JEE 2024 questions. In my all sessions, whatever I'm taking here, I'm completing the theory part, and I'm also providing you the solutions for the JEE 2024 and the 2023 questions. So this is what I'm doing. So now, what is going to be your approach? No, you have to provide the ratio, right? You have to provide the ratio. You know what? Whenever anything is moving in a circle, Remember this rule. This is my rule. Whenever anything is moving in a circle, there must be a centripetal force, right? There must be a centripetal force. And how we can get the centripetal force? Centripetal force will be acting due to the spring force. So I can write that spring force, F spring force, will be equals to F centripetal force. Right? Spring force is Kx and the centripetal force is mv square divided by r. And there is some extension, and we know that v is equals to r omega. V is equals to r omega, so I can write this as m r omega square. So this is my formula which we generally use whenever any object is moving in a circular path. So now you can replace one thing. K is already given to you. K is already given to you, 12.5. X we do not know, I think. Yes, X we do not know. We have to find out X. The mass is given to us 200 grams, so you could take it as 0.2. R, basically we have to replace this R with X, the extension, plus the natural length L, and omega square we have 5, 25. Okay, now that will become 0.5, 12.5x 0.5 into x plus L. We'll get 12.5x is equals to 0.5x plus 0.5L. 12x. Now you have to find out spring extension of spring to its natural length. Is there anything we have missed? Something? Omega square is given to us. What is the solution you are getting? Are you getting the same thing? Five, 12. It I'll do. Okay. That comes to be 5. And if that comes to be 5, then my get changed. So that will become 5x plus 5L 7.5. 7.5x equals to 5L. X by L is equals to 5 divided by 7.5, 50. Then I'll be getting 2 by 3. So my 2 by 3 will be answer. Okay. So approach must be clear to you because this is the utmost thing what you can do. See, whenever you are seeing a question, the first thing which comes to your mind is the approach, and that must be coming within few seconds of starting the question. right? Can we move further? Let's move towards the next point. Now, this question is from 24th January shift 2 paper. In this question, a mass M is attached to free end of a spring. Execute SHM with a time period of 1 second. Okay, time period is given to us. When there is a spring and there is a mass attached, the time period is 1 second. Okay. Now, the mass is increased by 3 kg. Okay, so if the mass is increased by 3 kg, you have M plus 3. The time period of oscillation increases by 1 second. That means the time is 2 seconds now. Now, you have to find out that what is the value of M. What was the value of M? As we know that getting the value of time period is very easy, because we know that time period is 2 pi under root M. Manoj Kumar sir. So it will be M divided by K. The K will remain same because we haven't changed the K here. This is my time T1, and for time T2 you will be having 2 pi M plus 3 divided by K. If you replace this T1 divided by T2, you will be having M divided by M plus 3, right? And you can write it here 1 divided by 2. You can do the square. 1 divided by 4 is equals to M divided by M plus 3. And here you will get M plus 3 is equals to 4M. So you will get 3M is equals to 3. M is equals to 1 kg. You have just increased the 1 kg here. Are you getting? What is the real approach of solving this question? I hope that you are familiar with the formula for the time period using my name, Manoj Kumar. Time period is equals to 2 pi under root M by K. Just you need to remember only my name. And once you remember my name, you will be able to solve this question within few seconds. Let's move towards the next question. This question is also very, very important, and this question is directly from H.C. Verma, I would say. In this question, a particle executes SHM between X. Okay, a particle is executing the SHM between minus A and plus A. Between minus A and plus A, there is the origin. Time taken by particle to go from X is equals to 0 to X is equals to A by 2. Okay, from here to here, from X is equals to 0, from X is equals to A by 2 is 2 seconds. Now you have to find out that from here to here, you have to find out that what is the time period. You know what? Just imagine in terms of the sine graph. In sine graph, we know that the values goes from 0 to 1 at pi by 6, that is 30 degree. At pi by 6, that is 30 degree, you will be getting the value as 1 by 2. But after that, there is so much you have to cover, because for 90 degree there are 60 degree more what you need to cover to get the correct answer, right? So I know that my answer will be more than 2 seconds. My answer will be more than 2 seconds, right? So this won't be my answer. Are you getting? See, the first and foremost thing what you need to do is you must know that what could not be my answer. So I know that my answer could not be 2 seconds or a less than 2 seconds, right? So now the only option which is left here is 3 and 4. So you have to do something, get the answers. Can you do? Can you know what is the approach here? Can you know what is the approach here? See, I'll be having one approach like here. I'm having a 30 degree. I'm considering this time T1 as 2 seconds. To cover this, To cover this 30°, I'm taking 2 seconds. And to cover this 60°, because from 30° to 90°, again 60° is there. So I would be taking t times 2 times of t1. So I can tell you that it will be 4 seconds. Okay. That would be my answer. Very easy to solve it. Now let's move towards the next question. A particle of mass this much executes SHM under a periodic force. Force is given to us, and force is equals to minus 25s. This is k here. A particle attains a maximum speed. This is equals to minus of kx. So k is given to you. Mass is 0.25 kg. Maximum speed Vmax, and we know Vmax is equals to a omega, right? It's given to us 4 meter per second. We have already derived the formula for Vmax. I hope that you remember the formula we have done here, right? Here, Vmax is equals to a omega. So this is what I'm putting here. Vmax is equals to a omega. So Vmax is equals to a omega, and that is equals to 4. So they are asking you that what is the amplitude of the SHM. Okay. Now tell me that how you are going to approach, because you know that the value of there is a relationship between k and m, right? So omega square is equals to under root k by m. Omega square is equals to under root k by m. And if we are comparing here, k is, I can write k is 25. Omega we do not know. K we know. Mass we know. You can substitute here. Omega is equals to 25.25. Just substitute. You'll get 100. You'll get 10. So omega is equals to 10. And if omega is equals to 10, you can get amplitude, because a omega is equals to 4. A into 10 is equals to 4, and a is equals to 0.4. Okay. Now you have to tell me the answer in centimeter. So what is the answer in centimeter? We have calculated in, yes, 40 centimeter. So your answer must be 40. That is what you need to get. You must be very active while solving the JEE questions, because it's a recent pattern which we are seeing, that in every question, even if you got the correct answer, you have to change that according to the conditions of the question. Why they are putting it? Because it might happen that somebody is solving in CGS system, or somebody is solving in MK system. If they are not providing you the options, so there must be a particular value what you need to enter in this question, right? So that's why what they are doing is they are keeping this in such a manner. Swan, I hope that this thing is clear, Swan. Is this thing clear? Shall we move? Let's solve the next question. Next question is, this question is from 30th Jan shift 2. According to this question, the general displacement of a SHM is x. That means displacement is given to us a sine omega t. Let t be the time period. The slope of the potential curve will be maximum when, okay. So they are saying that the slope of potential energy curve will be maximum at t is equals to t by beta. You have to find out that the value of beta. So how you are going to find out? Tell me how you are going to find out. At what point the potential energy will be maximum? minus A plus A. And I know that at this point my potential energy is maximum. At this point my potential energy is maximum, right? Right or wrong? At this point my potential energy is maximum, right? So at this point you could say that the angle, if I'm starting from here 0, that is pi by 2. So you could write 2 omega t is equals to pi by 2. Okay. So omega t is equals to pi by 4. And omega is equals to 2 pi by t. T is equals to pi by 4. T by 8. So my answer will be 8. Beta's value will be 8. Are you getting that? Ayush Tiwari, hi. Where are you from, Ayush Tiwari ji? Where are you from? So my answer will be 8. So beta values is 8. Now let's move. Okay. This question is very simple. What we need to find out? We need to find out the ratio of omega 2 by omega 1. Okay. So what is omega 2 and omega 1? SHM is happening between this, then this is surface. When the block of mass 1 kg, the angular frequency is omega 1. Okay. But when a block of mass is this much, and what is the... Okay, this is very simple. We know that... See, we know about the time period. Time period is equals to 2 pi under root Manoj Kumar, right? And omega is equals to 2 pi by t. Omega is 2 pi by t. So omega is basically under root k by m, right? Omega is equals to under root k by m. And if k is same, I could say that omega 1 divided by omega 2, or you have to go other way around, omega 2 by omega 1 will be equals to m1 divided by m2, under root m1 divided by m2. This is a very simple formula, means you must know. So easily you can get the correct option 1 divided by root 2. So my answer. Okay. Now this is the last question, and after that we will wind up. Please let me know that what is the correct answer. I'm giving you few seconds to solve this question. Tell me. The velocity of a particle executing SHM varies with displacement this much. Varies with displacement this much. The time period is given to you. The value of x you have to find out. Do it. You know what was the approach I told you? Whenever you face any issue while solving the SHM numericals, please remember my approach, what I have told you. I've told you that whenever you are solving the SHM numericals, you need to think in terms of the examples we have discussed, or in terms of the equation we have studied. So this is we are having. You could write it as 1 divided by 2 under root 50 minus of x square. Can you? And you also know that v is equals to, remember that what was the value of v? I already told you that we have to only think in terms of the equations we have studied. So we know that v is equals to this much. Keep v here. Why it's not being copied? Okay, v is equals to omega under root a square minus x square. Even if it's not copying, I can write this. Right? So from here, if you compare this thing, because this is the general equation, right? This is the general equation, and you can use this general equation. Compare this general equation, you will get omega is equals to 1 by t, and omega is equals to 2 pi divided by t. So your t will be equals to 4 pi. Right? Time period will be equals to 4 pi. Right? Are you able to get that? Time period will be equals to 4 pi. And the time period of oscillation is x by 7 is equals to 4 pi. You have to calculate the value of x. So it's 28 pi. 28 pi. And value of pi is also given to you. So you have to place that value. X will be equals to 28. 22 by 7. 4. X is equals to 88. 88 you have to put here. 88 you have to put here. I hope that this thing is clear. Yes, 88 is the correct answer. Okay. I hope that this thing is clear. Let's do one more question. Then we wind up. So this is the question from 31st January, shift 1. Maximum potential energy of a block executing SHM is given to you. A is the amplitude of oscillation. At A by 2, the kinetic energy of the block you have to get. That what is the kinetic energy at A by 2. Now remember this thing, that at A by 2, it won't be half of 25. So it won't be half of that thing. Okay. So please remember that thing. So I can say that this wouldn't be my answer. This wouldn't be my answer. And at maximum, see, its maximum potential energy is given that it's 25 joule. So my answer would not be more than that. Are you getting my point? My answer would not be more than that. Right? And we have already discussed a similar type of question in which one object was moving from 0 to the maximum value, and here basically we are having a by 2. From here to here we have 30 degree, and from here to here we have 60-degree difference, right? So we have discussed one question related to the time. So if this is the time t, this will be a time 2t, right? So now think in terms of the energies, that what could be the answer. Do let me know that what could be the answer. Suraj, Ayush, please let me know that what could be the answer. You can use the kinetic energy equations here. What is the value of kinetic energy? Because it's asking you only the kinetic energy, right? So I hope that you remember the kinetic energy formula. You remember the kinetic energy formula? Have you? And this type of pattern is so important that you must remember. See, potential energy is given to us. That is 25 joules. Half kx square we are having, right? Half kx square. And we know that omega is equals to under root k by m. So k will be equals to m omega square. So you can replace this. 25 is equals to half m omega square x square. And for maximum, here you are having a square. So this is the equation number 1. For the kinetic energy, we have half mv square, and v is equals to omega under root a square minus of x square. Okay, and x is basically a by 2. If you put a by 2 here, I'll be getting a by 4 omega a square minus a square divided by 4. So I'll be getting root 3 will be the this will be my value for v. And if you find out kinetic energy, you will get half m v square. So I need to square it 3 by 4a, and you can replace this half. The value of this is 25. So your kinetic energy will be equals to 3 by 4 into 25. So you'll get 18.75, right? You'll get this answer. This will be your answer. I hope that now it's clear. Now it's clear, my dear. The answer. Now, similarly, again, in the next question, this is similar to the previous questions we have already done. So other than that, all are your homework. Okay, so I have keeping 15 to 17 questions here. Similarly, this is the question from JEE 2024 January attempt. So all these questions in this PDF is your homework. Now, first thing what you need to do is join our Telegram if you haven't. So join our Telegram group, and in that Telegram group you will get the PDF for this class, and also you'll be getting the PDF for the questions which will be there. Okay, so and do share these sessions with your friends, because in the next sessions I'll be covering the modern physics, I'll be covering the dual nature, I'll be covering the atoms and nuclei. So these are very, very important chapters, and there are a lot of practice questions will be coming towards your way. Okay, so best of luck for your JEE exam. We will meet again in the next class, and next class will be on Saturday for physics. Tomorrow you are having a session for chemistry, I think. Okay, so bye bye.